understand that uh, most of the material has been learned in the high school. So I think most of the thing is quite familiar for all of us. But I will point out something that I think it's sorry. Uh, I will point out something that I think a little bit different than what you have learned before. So basically, main difference is for example, in the high school, usually we only learn about a function that continues. So what I mean is, so for example, we have this is x and so for example, this is x and y. X. Oh, make sure when you draw, you make it clear which one is y, which one is x. And after that, usually what I mean continuous is a function that on something like look like this. Yes. So for example, it is
Sorry, you are writing on the screen, right?
yes, yes, yes. Can you
Uh,
see?
it freezes, right?
Oh,
Or it
it
is
really
just
is.
me,
Oh,
right? Can others?
okay, okay, okay. Is it okay now? You, you can
Uh,
type if you.
I still cannot see the annotation. Yeah.
I just
Mm,
did a presentation.
wow. Wait. Okay, okay. Sorry. Uh, because it's look clear to me. Wait, I will stop sharing. Now I share again. Share. Ah, is it okay? Oh, I think yeah, yeah.
Yeah,
Yes.
yes, we can see it.
Okay, so okay, let return. So as I said before, that basically in the high school you only learn about function that continues, something that look like this. Now in the in our calculus, function doesn't need to be continuous like this. It can be what we call as piecewise linear, something like this. Uh, so, sorry. Yes. And then yeah, something look like this. So for example, this is this is y y equals to let's say x plus 8 when x oh, okay, I will write here. So this function y is equals to something like this, x plus 8 for, let's say, x smaller equal to -3, then that's equal to, let's say, 3 when x is between -3 and, let's say, smaller than 7, and after that, let's say x equals y equals x plus 2 2x plus 2 when x greater than 7. So I will, this is x, this is y, this is -3, -3, something somewhere here, this is 7. Yeah, so I think that's my what main difference between high school and now. And as you can see here, that's why we need to learn about domain, because when, as you can see, when we change the domain, when the domain is smaller than -3, the function is not the same as when -3 to 7. So now the function can change when the domain change. So yeah, we will deal something like this. Everybody understand, or it is confusing? Okay, good. That's one of the main difference. Another difference is, so as you can see here, we have something look like this. So you can see that yeah, we have a lot of piecewise linear example. Another thing that's different is usually in calculus, you cannot just give an answer without explanation, because uh, what more important for us as engineer is how do you think, how you get from point A to point B, because oftentimes, especially in engineering things, there is more than one solution, and we cannot say most of the time we cannot say one solution is better than the other. So we need to explain it to persuade even our colleague in the when we work or now in the class. When you do your exam, you need to persuade the professor that you understand the problem, the question. So if you just write the answer, then uh, it is not so persuading the for us to see. Do you really understand, or you just copy from somewhere else? I think that's another point that's important. Uh, okay, so if I may ask you, uh, yesterday, Professor Iman teach you until when? Until have you guys learned composition in the class?
I think not yet. Like the last thing we finish is about the definition of limit and the example that when we increases the size of the polygon until it reaches circle.
Oh yeah. I understand. Uh, I think. Oh, that's more than function. Okay, so okay, let us talk about limit. Hmm. The concept of limit is, I think you have been learned in the class. So nothing too much detail. I will not repeat much, but it, I think the problem with the limit, the difficult part of the limit later is not the limit is difficult, but you must uh, you must how to say you must do the algebra manipulation that the algebra manipulation can be quite hard. Okay, let us see. Well, okay, let's see some simple. So let us see something like this. So, what is the limit of f(x) when x equals to here? Anybody? An answer? Any idea? Any clue?
Uh,
Yep.
what number, sir?
Yes, the answer. Well, when x limit x to the 2.
It's 5. Like the first question, right? The first question, right? You mean like the
No,
first
C.
C?
This C.
Oh, I
The
see.
C. Yep. What is C?
Uh, the limit doesn't exist, right?
Because
Like the limit from like the negative side and the limit from the positive side is not equal.
yeah. So yeah, in order for the limit to exist, you must the left side and the right side must be equal. And here we see that from the left, the answer is 3, but from the right side, the answer is 1. So doesn't match. But if the question is not the limit, but what is the d, the f when f equals 2, then the answer is this is equals to 3 because the f2 equals to 3 here. Okay. Okay, that's easy. Now let us see this one. So my question is, what is the limit at x equal 4? Any idea? Any opinion? Okay. Okay. Can you see my pointer? So, yeah. My question is, what is the limit of h? I believe it is not f here. It h. Yes, the function is h when it is equal to 4. So this 4. No, no, nobody asked about 4, but yeah, that's my question is. Sorry, not 4, 5. 3, 4, 5. Yes, 5. What is the answer? What is the question of? What is the answer of when limit x to the 5? Huh? Any clue? Anyone want to answer this?
It does not exist.
Why?
Like the value fluctuates when it approaches 5.
Mm-hmm.
Like you cannot really like see the exact value uh that the function is when x approaches 5.
Yep. Okay, so this is an interesting idea because as you can see in the previous question, this one, uh, the limit doesn't exist because there are discontinuity in the two, so they are jump. So the left and the right doesn't match. But here in the 5, the function is indeed continuous. But the problem is we call it their oscillation. So because of the oscillation, uh, we cannot pinpoint what is the value of 5. So in this condition, we also say that the limit doesn't exist, even though the limit of from the even though it is continuous. So the left and the right side will be the same, but still doesn't exist. Okay. Do you guys have learned about asymptotes or not yet?
I think not yet in this course.
Oh, not in this course. Oh, okay. Thank you, Helen. But it's okay. So basically, asymptote is a line that uh that you guys the function is approaching that line, but it never met. So that's asymptote. So that can be vertical, that can be horizontal, or even a diagonal. So let us see. Does that use geotechnical stuff? Can you explain what do you mean by geotechnical stuff? please, because I'm not sure we understand the same thing about geotechnical things. Hello? Can you explain? Can you elaborate more? What do you mean by geotechnical stuff? Oh, the direction on a land. Ah, I see. No, not yet, but how to say? Calculus, mathematics that we learn in the class is the more idealized condition. So in the real life, the condition is much more complicated. So we don't use even if the even if we use the real life example can be direction on the land, on the mountain, we don't really use the real example because that's too complicated for our course. And I think that's hopefully can answer your question. Another thing that I want to uh, oh, okay, I will write my email address. Yeah, I have write my email so everybody can see it and you can send it to that. But you're welcome. But you can also ask me in the Moodle, either by messaging or in the forum. I think better in the forum so everybody can read and can learn together. That's why I post these tutorial things in the forum so everybody can replay and can ask. And I think it's better if you have something you ask sooner. You do not need to for the TA session. You can ask anytime you want to ask because in that way I think I have more time to answer your question because we only have 1 hour more or less, so maybe that that's not enough to answer everybody question, especially later because right now there's not much question yet, but still is. But okay, now I want to another point that I want to share to you is uh, it's one being very good because I'm not so used to in using in the computer, but I will try my best. You know? Okay. Another thing that I want to share is you guys must must be must able to draw, to graph. I mean, it is calculus, not a drawing class, so your drawing doesn't need to be good, but it must be clear. We we must be understandable. Okay, so for example, I want to draw number 12 here. Okay, everybody can see my. Okay, I think yeah, everybody can see my slide. So for example, here, yep, this is X, this is Y. So yeah, I want to draw number 12. Um, so how to draw it? Any idea? Okay, let's say some point. This is -1. This is 2 because -1 and 2 is two boundaries here, and this is the screen doesn't change. Oh yes. Wait. Okay, yeah, I see. Okay, again and again. Okay, wait. Yes. Oh, Paulio. Yeah. Okay. Let let us. Sorry, doesn't change again. Sorry. Hey, yeah. Why? Paulo. Ah, everybody can see that, right? It's ugly, but we have what we have. So yes. This is minus. This is minus a, and this is -1. This is -2. So how we draw it? Okay. So in the minus 8, the square root of the square root, sorry, the cubic root of minus 8 is minus 2. So here, and minus 1 is minus 1. So here. So we have something like this. So it should be smooth, not a straight line because it is cubic root. And after that we have between minus 1 and 2 is 2 here. So we have something that is more or less. Sorry, my drawing. Yeah, 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 yeah. Let me try again. Sorry. Take. Ooh. Sorry. Uh, it should be straight line, but the important point is it is in the minus 1 is 1, in the 0 is 0, and in the 2 is 2. And the last part is x minus 1 square for x bigger than 2. So 2 minus 1 is 1 square. So something like this. 1 here, and yes, we have quadratic. So something like this. Everybody can see. Sorry, uh, the drawing is ugly, but hey. Any questions so far? It's easy, right? Uh, ah, Let us see another things from the book. Okay. Ah. Now we sorry. Okay. Hmm. I think nothing interesting here. Let us see. This limit law you guys haven't learned yet, right? Or you have learned it? I don't think so. Right? No. Okay. Well, basically you have learned it in the high school, so neither here nor there. It's not that hard. Basically, you just say that yeah, you can uh, get the operation out of the limit. So you can put the limit. So this plus is inside the limit in the beginning, but now it is outside the limit. That's it. Uh, Nothing really interesting. Uh, I think that's. I think we have hit the more important point in this tutorial. Anybody want to ask something or not yet? No. Okay. I disappear. Okay. Uh, oh, by the way, anything about function, domain, codomain, about the chapter one because we Professor Iman has teach until up until chapter 2.1 in this book. So I think you need to learn by yourself about function, about domain. I think I have glossed quickly, right? That why it's important to learn about domain and function, and the function and domain now is become more a little bit more complicated because you cannot just assume that everything is in the real line. You cannot just assume that the function is continuous. You must you must ensure that the function has that properties, either continuous or what is the domain, because now uh, everything is not that easy as high school. Other things that I want to show is, sorry, uh, two. Ah, okay. This is the review question in your book, and from my experience last year, basically the format of in the exam will more or less follow this kind of format. So there is a theoretic question, true or false question, a little bit, and then the normal things, and in the last, I think there is one or two question that really hard. Something look like a problem plus. Some not from the problem plus, but uh, more or less in the same category of difficultness. Okay. I don't find something interesting to be honest here. Okay. Oh yeah, I found one. Anybody? I think everybody can you try to do problem one here? This is easy, right? Can you try to do this and what is the answer? Maybe I will wait. Or do you think I need to do this or you can do by yourself? Any input from you? What do you think? This question is too easy or too hard or what? Hello? Okay. Okay, okay. Okay, give I will do it. Don't worry. So sharing, share a window. Share. How? Yep, it's 2/3, but how to do that? So basically, this is the same as x power of 1/6 square minus 1 over x power to the 1/6 cubic minus 1. A- Anybody confused about this thing? No, right? Ev- Everything clear. So until now, right? Why? Because this the above is x power to the 1/3, right? 1/3 is equal to 1/6 square. Okay? Okay, I assume you guys understand that. Now I substitute x with something else to make it look nice. For example, a equals to x power 1/6. So this one become limit of a approaching 1, a square minus 1 over a power 3 minus 1. Okay, that's just substitution, just to make it nice for us. Equals to limit x a to the 1, a minus 1 times a plus 1 over a minus 1 over a square plus I forget. So look, a square, a square minus 1 plus a square minus a minus 1 plus 1. Yep. Thank you. Plus a plus 1. So we can simplify this because this one is the same from divisor and subtractor. Oh, vice versa. 好，继续。Okay, sorry for the incident. So this is one a plus 1 over a square plus a plus 1. So it's become 1 plus 1, 2 over 3. 1 plus 1 plus 1, 3. So that's it. That's what I want to emphasize is the limits usually not hard. The algebraic manipulation can be tricky. I don't say hard, it's tricky. When you know, you know. So not that difficult. Anybody want to say something? Any response? Anything you want to say? You can say or type. No? Okay. Otherwise, you're welcome. I think that's all for today. Thank you very much. Okay, thank you very much for welcome for attending this session, and we will meet again next week. Thank you very much. Bye bye.
Thank you.
Thank you, welcome. Bye
Thank you,
bye.
sir.
Okay, welcome. Bye bye.